All right, so everybody's presenting today?
Yep.
All right, awesome. And I saw Riley said something about maybe next week. Okay, well, go ahead. Cool. Okay, let's go ahead and get started. I was working with a friend of mine. So my alarm didn't go off, so I woke up like 15 minutes ago. And I was up till 3 with the baby, so hang on while my brain turns on. I probably should, anyway, we'll just go ahead. It'll be fine.
Got the best excuse out of all of us.
All right, let's go ahead and get started. So just a couple of things that I wanted to share. Is the screen on full screen now?
Yeah.
Okay. One was I was working on something else and came across OpenMapKit, which is looks like kind of a neat way to do mobile data collection. So oftentimes we use like ArcCollector or something like that for that job. Of course, that's you need access to Arc to do that, and sometimes it's nice to be able to work in the open source world. I haven't tried this out yet, but it looked pretty cool. So just kind of keep it in mind if people are ever doing field data collection or just want to try it out and see if it works out. Could be kind of a neat way to do it. I also ran across this on another project, the High Pointers Club. Have you guys heard of this?
No.
So they put like these markers down in every state, and I don't know, maybe they're doing it with more than just states, but definitely for every state, they put a little like marker down, like it looks like a USGS like bronze marker, but it's just for like the highest point in that state. So a friend of mine was working on doing some archaeological work in one of the parks in DC, and he ran across one of these things. But seems like kind of a cool thing. So if you ever want an adventure, try to stop by one of these things. I'll probably try to check out the DC one. And I didn't look to see where the Virginia one was. Is that Mount Rogers or something in Virginia?
Yeah.
Anyway, could be fun. Other news, I saw, Google keeps telling me about these things. This is a solid state LiDAR. Many of you may know that this is kind of one of these things that I'm really, really hoping to get for the lab, and I've been hoping to do that for about 2 years. And there's just been like delay after delay in getting these things out. I'll probably wait for the Velodyne model, but for $3,000, it's probably within, definitely within our price range. Supposedly the Velodyne solid state LiDAR is supposed to be even less than this, like less than 1,000. Plus Velodyne has a lot of experience in this domain, so I'll have to give it some thought, but it's cool to see solid state LiDAR finally on the market. Unlike kind of the current units that spin, this is just kind of like a forward-looking unit. I've seen some other things that have sort of like multiple sensors and they integrate those things. But for a lot of what we do, just kind of a forward-looking system would probably work okay, especially if it's mounted on a drone and just looking down. So I don't know, cool to see. Maybe that's actually on the market. I won't go into a lot of detail. The paper that I reviewed, this is the paper that I reviewed to make revisions to the paper I did with Earl. So Earl's thesis is it was submitted for publication. We're doing some revisions right now. I was gonna check this one out. One of the reviewers said, oh, you should cite Kenny et al. 2011, which often means that Kenny was doing the reviewing. But this was kind of an interesting article. Mainly, they were trying to update a way to quantitatively say how good the urban forest is in a place. And so they had all these different metrics that would kind of speak to that. One was relative canopy cover, which was the amount of measured canopy area versus how much there could be. So they called this potential canopy cover. That potential canopy cover is probably the stickiest measurement in all of that, because what does it mean? How do you determine what the potential canopy cover of a place is? The other one that I thought was really interesting was relative diameter. So they were trying to make a case that the trees should be diverse, not just in like species, but also in age, so that all the trees aren't all the same age. So they used relative diameter as a means to capture that, where they measure the diameter of the tree, but then they take the maximum potential diameter, which is sort of the how big could that tree get, either based off of sort of like published literature values. I suppose you could also kind of use the biggest one in your study area as a rough metric for that, as long as you were pretty sure that you got one that was about as big as it could be. But pretty interesting stuff. Otherwise, how many of these things did they say they had? It was like 20 some different metrics, which seemed like probably no one's really going to do that. They had a number of other things that were sort of related to like how well that data was digitized and how well it existed in a GIS system. Probably the lab is going to swing back at some point and try to do more LiDAR point cloud based imaging of urban forests. So this was kind of a good thing to know. This was the table that kind of summarized it. So basically, you've got all of these different criteria on the left, and then you rate these things on low, moderate, good, optimal. So just kind of a 1 to 4 scale, and they give values here. So if it's 0 to 25% of the potential canopy, then it gets a low or a 1. If it's 75 to 100%, then it gets a 4. So you just kind of go through and rank all of these things. So then you can say the average value with it was this, or the total score was that. I was doing a little bit of work on the Python side and ran across this little package. So this is called TIFF file. TIFF file looks like it's integrated into Skimage or SKImage, and I don't know. I never did use it through that window, but probably this is of most interest to Sam at the moment. But the nice thing about TIFF file is that it will read a format called BigTIFF. Have you guys heard of that one? Exactly. So it's for really like extraordinarily large TIFFs. So I think the current limit is something like, I don't know, 30 gigabytes or something like that in a single TIFF file, which is big. So if you want to go bigger than that, then you need this BigTIFF library, which happens more often than you would think. That sounds pretty big, but when you start to record things at really high resolutions, whether it's I needed a BigTIFF, for instance, when I was making a 1 meter LiDAR image of Chicago. Chicago was big enough to drive those file sizes up at that resolution. So anyway, just kind of keep that in your back pocket, BigTIFF and TIFF file on the Python side. I got a note from Howard Butler last week. So this was the guy that is behind PDAL that Hudson and I spoke to. One of the nice things about actually talking to people was he was like, hey, you've also done this other work on the perceptually shaded slope model. Would you like to try to fold that into GDAL, which is great. So we'll probably do that. One of the things I wanted to mention was, so we often use, there are a number of different toolkits that we use in the lab, but GDAL is one of these tools that kind of exists underneath a lot of tools. So usually it comes with QGIS, it comes with ArcGIS, although Arc has its own sort of functions that do most of the work. But GDAL is free. It's open source. It's got a ton of things it can do. When we start working more on the Python side, you'll see a lot of stuff that it can do. But one of the things that I'm noticing here is that basically where they wanted to slot in the perceptually shaded slope model, they've got other things in here like the terrain ruggedness index. So GDAL can calculate that natively without the need for anything else. So those little things, if we're working within Python, we're already going to be using GDAL, and that sort of makes TRI just like immediately available to us. So I know that Sam and Jim may both have applications for this. So kind of, again, keep that in your back pocket. It may be a couple of months before you're going to need that, but it's good to know that it's out there. In the process of doing that, I actually also ran into a mild bug, so this is probably mostly of interest to Sam, but I updated the NeilPy repo that's up there. I only made one little change, so when you fold your changes in, it shouldn't really matter, and it'll be good test for GitHub, because GitHub is supposed to be able to do this without any problem, and that's its sole purpose for being.
Yeah.
So I don't think it's going to be an issue, but I wanted to let you know. What I had done was folded in this vertical elevation value and hard coded it into one of the lines. So classic programming mistake, but easily caught. What I was doing was I was trying to change this VE parameter and set it to different things like 1 or 5. Jim, when I was this came up when I was working on the landslide data for California that you had pulled. So when I went to go make a visualization of that, it was a lot darker than I wanted it to be because it's a really rugged area. Usually I apply this stuff to kind of more urban areas. So anyway, I couldn't change the value. It was always coming out the same, and it took me a little while to figure out why. This is what one of those things looks like, by the way. So this is a perceptually shaded slope map of a spot at DSM in Berkeley. So what the PSSM routine does is it essentially calculates a slope value and then exaggerates that a little bit according to a particular kind of a curve, and then applies a shading routine to it. So it's essentially kind of a riff on standard slope shading. But the reason that it's kind of nice is that it brings out a lot of detail. And so I think it'll probably be useful for certain kinds of DSM inspection. Well, it is useful for that. Last little comment here. Last week I was off at the board meeting for CAGIS in DC. So CAGIS is the Cartography and Geographic Information Society. It's kind of one of these like relatively big national organizations that kind of promotes the discipline. And AutoCarto is kind of their big conference, and that kind of brings a lot of big names out. And that's going to be at Esri this year. So while I was at the board meeting, I was on the subway and I was talking to Dan Cole, who's the head cartographer for the Smithsonian. And we weren't even really talking about, I don't remember what we were talking about, but he was like, oh, I think I mentioned the Inca Roads thing. And he was like, oh, I actually digitized the whole Inca Road network a couple of years ago for an exhibit. I'm like, oh, that's amazing. I have a graduate student that could really use that. So he was like, sure, I'll send the data right over, which he did on Tuesday. I think that is now shared with Colleen. And I just wanted to like bring this up as really kind of a thing of like science is really a human endeavor. So it's all people that are driving this stuff. So the more you can talk to people and have conversations and learn their names, that's a really important part of kind of doing the science. So when you guys are working with your literature, don't just pay attention to the titles and the abstracts, pay attention to the authors, because you'll actually often get to know some of these people as you go on. These are real people. I mean, Hudson and I had this experience talking to Howard Butler a couple of weeks ago. Like these are human beings, and they would love to talk to you about your research. So I'll leave it at that. So, all right. Oh, sorry, I did have one last thing. I forgot I added this late last night. So the friend of mine that was doing archaeological work in the park in DC had just purchased 2 multi-band Reach RS2 units. So this is a really high precision GPS. It's an RTK receiver, but it's sort of the 3rd iteration of this from EMLID. So I bought the little Kickstarter ones. And then for the lab, there's these little like M+ ones that go on drones. And there's a unit that looks like this called the RS. I think it's just called the RS.
They have RS and RS Plus.
RS, maybe we have the RS Plus. And Jim, you've worked with these a fair bit, right?
Yeah, they're pretty cool.
So the RS2 is kind of the newest in this lineup, and it's got multi-band RTK. And the really awesome thing about this is that we were able to achieve better than 1 centimeter accuracy in less than 30 minutes, which I need to go back and check the RS Plus, which we have, and see how good it can do. But I was pretty impressed. A lot of this stuff, they sort of put out estimates of accuracy, and sometimes those are not as good as they could be. So even this RTK unit that I had would certainly not do anything this good. It would have been down to less than a meter maybe, or a half meter, but it wouldn't have been 1 centimeter accuracy. So pretty amazing stuff. And just as kind of a note to self and for anybody else that might be using the RS down the road, there is a special version of RTK Lab for the Reach RS2 that you have to download. So you can't use the original branch of the MLID RTK Lab. You have to use this one that's written especially for RS2. I think I pinged Jack about this. I've been kind of really interested in rovers for the last couple of weeks. So I think we're probably going to build one for the lab at some point. So essentially the same autopilot, the same brain flight controller that we put on drones to do them, to let them fly autonomously, you can put on lots of different kinds of vehicles. So the ArduPilot flight controller for that can go on rovers, it can go on boats, it can go on a lot of things. So the nice thing here is that, you know, drones are great, but they have their limitations. With a vehicle, we've got the opportunity for longer and much more in-depth flight scan times. So if we wanted to, for instance, run a LiDAR through an agricultural field, we could scan that and we'd get a much, much denser point cloud than we could get even with a drone. And even if we did put a LiDAR on it, but that's extra money. So the rover, we could basically pile on as many instruments as we want. It's much, much cheaper to put on heavier instruments. Size is not a limiting factor. So I think it's a pretty interesting opportunity.
Yeah, I think the real sense would be real good.
Yeah, good point. Yeah. So I think we'll probably do this in the spring when I get back. I'm kind of putting some feelers out to see what it would take. It's really as easy as taking an existing like radio control car and just kind of adding the flight controller to it. So that part is pretty easy. Scaling these things up, I've got some ideas. Actually, one of my favorite new ones is I saw there's a way to convert those like kids' Power Wheels cars to an autonomous rover with this. So that would be a pretty easy, fun one. Buy $120 Power Wheels, and then we can kind of make something a little bit bigger. My idea is to use things like the motors that go on like scooters for the elderly. Those motors are pretty powerful and they're pretty inexpensive. So I think we can probably put something together with those. Okay, that's it for me.
I mean, if we get the if we get the Power Wheels thing, we take the engine and everything out of it, then can we do those downhill redneck things? Have you seen those videos? It's cool.
I'm in the process of building my own electric skateboard, so it's like all that kind of like power supply stuff. Much fun.
You're building an electric skateboard, Hudson?
Yeah,
How's it going?
it's going good. I'm just kind of assembling all the parts and getting all the ESCs associated with it, trying to figure out like best specs for just like pulley sizes versus like the amount of like watts and that the motor is going to pull out. So
Cool.
yeah, there's a lot of different ways you can go with it. You can go a pulley system, or you can go like a in wheel kind of deal system.
Cool. You have to bring it in and show it to everybody. I'm very interested in that kind of stuff. Those self-propelled skateboards seem like a really nice, efficient way to travel.
Oh yeah. You get a nice. Yeah, the stopping part's a little hard, but
Yeah.
but they you strap a nice like 11 series battery onto it and it'll go for a long time. So 15-20 miles of range. So
Cool.
We got some. Here's mine. My first part is at a couple meetings. One was with Sean Bemis. He's in geosciences, so he's a geologist, but he's done some photogrammetry stuff. He's mainly earthquake seismic focused and working in Nepal and on the west coast. That's where earthquakes happen. But he told me about this cool thing. It's NCALM, which I think is National Center for Aerial Laser Mapping. And this seed proposal, they call it, and it's basically a grant. They'll issue it to 10 grad students a year, and they'll survey up to 40 square kilometers for you with their LiDAR.
Wow.
Yeah, so the applications are due December 20th. So I think that's a couple of us might be interested. in getting that because it's free. Like you just tell them where to fly and you'll schedule their surveys.
Good.
And
Where in the world?
it might be just in the U.S. So
And it's
look it
free?
up. Yeah, I'll post a link in our Slack channel about it. But it sounds like a great opportunity. So, and one of his students has done it, and then like the data is forever available from like the national map, I think. So
Wow, that's amazing.
yeah, real nice.
And where will you post the link?
I'll put it in the Slack channel.
Okay.
And then he was talking about this modified structure for motion, and it's like it's for change detection. He's a geologist who does some of that stuff on earthquakes, and he's looking at like the San Andreas Fault, trying to match up like where it's slipped. You might have like a road or something that goes across the fault, and it's like moved a little bit. So what they're trying to do is like run their structure for motion with like the different images from the different times that we like all together or something like that. I was kind of confused. That's how it works because it's different. I need to read up. He sent me a paper. That's the title of it: the Joining Multi-Epoch Archival Aerial Images. So it seems really neat. Kind of confusing. Yeah. Then
That would be so I've seen some really interesting stuff from reality capture where people have taken, so reality capture is a like a different photogrammetry software package, and one of the things that they boast is that it's really good at taking these sort of disparate images from lots of different sources. And so somebody took, I forget what they were recreating, but some like building the tourists go to, and so there's like hundreds of images of this building. I wonder if you could do that with a ground surface, right? Pick a beach that people are at often, and see if you could do the same thing.
yeah. So I guess this is a good technique for getting the DEMs of difference. That's really the goal with a lot of these like change detection studies. But yeah. And also met with Dr. Crawford, and we just talked about some coastal monitoring. You mentioned some people at ECU and that's East Carolina University and UNC Wilmington that he's worked with who've done some similar like aerial photography of beaches and stuff like that. One of them used balloons instead of drones, which was kind of neat. And I think it's kind of just a cheaper alternative. It seemed a little silly compared to, like, it's a balloon, you know, so you can't like plan a flight and just like have it do it. But
So I did some balloon photogrammetry actually during my postdoc. So this would have been like 10 years ago, before drones got big. So there wasn't even a drone alternative.
yeah, like 2012, I think so.
Yeah. So it doesn't work super well, and the reason is that to get enough altitude, you need a pretty big balloon, even to lift kind of a moderate amount of weight. So we were lifting like a cell phone at the time and using that. I guess you could get away with something a little bit smaller now. Balloon or cameras are a lot smaller, but yeah, you needed a big balloon, and so the problem is that you know it would just kind of drift downstream a lot. Even a little bit of wind is going to push that balloon
Yeah,
off course.
this person had attached, like, made it sort of like a kite-ish, like had some fins, I guess, to stabilize it in the wind.
So they have so kite photography is actually better, and it's probably easier, especially on a beach where there's likely to be a little bit more wind. It always seems like beaches have a good wind source.
Yeah.
So one of the people that I was working with was Kitty Courier. I can maybe send you some of her stuff if you remind me. She did this whole like kite-based photogrammetry of like a reef system, I think. It's been a while since I've looked at it, but I think that kite photography is actually really pretty well developed. And then they make these combination things called helikites, or helikite is one kind of like half balloon, half kite, so it will fly but it's kind of in the shape of a wing so that it doesn't need, it's got enough lift to kind of get started, and to kind of stabilize itself, but then it flies on its own once it's aloft.
Neat. So that's that. And next thing, so Dr. Pingle was talking to me about the rovers maybe building an autonomous boat. And the lab I worked in at USC as an undergrad, it was this coastal processes and sediment dynamics. And there's a master's student there who was looking at these scour holes after a big flood event. It was October 2015. So like around this bridge piling, there's all this like turbulence and stuff, and it digs up sediment. So he wanted to build a boat that would have these 3D side scan sonars on it, and you could just drive the boat around, and it would get the bathymetry, and you could see how big these scour holes were. So here's a picture of it. It's basically a kayak with a water jet for propulsion and the side scan sonar and depth finder strapped onto it. I thought Mokai was the name, but that's actually the name of the company that makes the platform, the jet powered kayak. And so they use the Pixhawk as their autopilot controller. And they wanted to look at the bridge scouring. So they have a cool video that they sent me. Can you see this, Dr. Pingle?
Yep.
So this is the Congaree River, I think, near Columbia. And so the boat's just kind of going around doing its thing. And yeah.
Yeah, I couldn't tell if that was the boat, making the jet noise or.
Yeah. So yeah, the people. I remember we were at sailing practice one day and we saw this out there and we were like, "What the heck is this thing? What's going on it?" But this is what the sonar, kind of raw sonar data looks like. So we'll get to some bridge pilings and it looks really cool.
So the center is it's beating down straight at the.
Yeah, so you have port and starboard, so it's kind of confusing to look at it.
Yeah.
So it's scanning out. You can think of it like there's one beam that's scanning out to the port side of the boat, and the other on the starboard.
Oh, it's just stitched together.
Yeah, and then so the center is the boat. The black area in the middle is just
shadow. It looks like it's degree. You can't see
Yeah, it's like if you're looking at the sky from trying to make it look out at the sky.
What's the angle that you're aiming at usually? Is that 45 degrees or?
That's a good question. I think it's a swath of
Okay.
Straight down. Maybe not quite straight down.
So always back.
Well, so it propagates in a sphere.
That makes sense.
Yeah.
Okay. Interesting.
So so this is a bridge pile right here, and it's cool. You can kind of see the shadow behind it, and you can see the shadows behind these little waves and stuff. So you might be able to. It looks like there's a bit of a scour hole right here. Not sure which way is upstream here, but I make that out. A little bit.
Upstream is this way, down. Yeah, that makes sense.
Oh yeah, that makes sense. Yeah, because the way the sand waves are.
Yeah, that's what I was facing.
Yeah. So that's neat. There's another one. There's downstream scour hole. So it worked pretty well. They didn't end up publishing anything on it, but they did what they wanted to do. I'm not sure why they didn't publish, but yeah, that was pretty neat. And Doug was the grad student I was talking to. We were chatting a little bit about some stuff. You can get depth from wave imagery. Just had to do some math to tease the depth out of waves. It only works in 10 meters or less water depth stuff. So, yeah. Then some little housekeeping stuff. We got a filing cabinet because some of us like to print out our papers and not read on a computer screen. So yeah, the plan is
You can see
it's
it.
gonna organize each drawer by like subjects or related subjects. So like, yeah, there it is. And then alphabetically, and maybe make a table of contents on the wiki for those of us who like to print out our stuff. Sound good?
Dark ages.
Whatever.
Um,
There's
Yeah.
more of us than there are.
So the next thing I did was measuring beach lengths to get an idea of like study area size. So it would be nice to do the entire beach because like they kind of function like as a whole a little bit. But you don't really necessarily need to because beaches can be kind of big. So this is Virginia Beach, and yes, it goes up here. This is the base of the mouth of like Chesapeake, and down to this inlet is about 9.5 kilometers. I just measured it with the Google Earth tool, and that's pretty long. The next one I go is the Ship Shoal. It's not quite as big. It's a small barrier island, just north of, like on the northern mouth of the Chesapeake, about 1.5 kilometers. That's on the smaller side, but it's still pretty big. And it's also hard, like, it's a totally uninhabited barrier island. It's just like a big sandbar, pretty much. The other thing is on some of these more developed beaches, you get these hard structures that kind of contain the sand within them. You can see it has this like cusp shape that beaches have, like this C shape. And this is only, less than 500 meters long. So this could be a good area to look at. And these are also going to be the more developed beaches where people live and stuff. So it's that study is going to be more relevant. And there's these structures can be kind of controversial because they kind of accelerate erosion a little bit. Kind of counterintuitive, but like that's good. A lot of places have totally banned these. Like South Carolina, you have to go through a lot of hoops to get permits to build a new groin or jetty or something like that because the laws are. South Carolina is pretty good coastal management laws, and there's been also North Carolina's had a ton of lawsuits about these. So this could be a good area, or like looking at these developed beaches with lines and stuff.
Did Anna Maria tell you about Buffalo Beach? Or?
No, I was just looking at Google Earth and stuff. Did you do some stuff?
Yeah, we did like coastal, like the perception of risk to flooding.
Oh,
in
the
area.
surveys.
Yeah.
Cool.
Buffalo Beach is an interesting beach, man. It attracts an interesting crowd.
Okay. Yeah. So next thing is talking about bathymetric LiDAR. So it's used for depth sounding. It only really works in shallowish waters because the light has to penetrate the water all the way to the bottom and then back up. And most of these sensors are on airplanes, but there are some available for UAVs. And so, like I said, water attenuates light pretty quickly. This is a chart of how far the different wavelengths of light can penetrate. So blue and violet are the most, have the best penetration. That's why the ocean's blue. A lot of these use a green laser, and I have a couple ideas why that might be. It might be because of the way chlorophyll absorbs pigments. And also, this is like pure water, and this chart can kind of change the more stuff that's in the water, whether that's mud or phytoplankton and stuff. But so, anyways, they typically use a green laser, and you need pretty shallow water, and it also depends on the conditions. So, like all the companies that have their sensors will give you their ideal depth maximum, but you're pretty much always going to be less than that just because of the water conditions. And so there's Topobathy LiDARs, which combine the terrestrial service and the bathymetric LiDAR, which is really good for mixed land and water areas, like say a marsh, because terrestrial LiDAR sometimes won't work super well because it's a really like tight mesh of wet areas and dry areas. One of the big challenges in doing this though is accounting for the refraction as the water laser enters and exits the water. That changes the angle of it a little bit. So, yeah, like I said, it's good for mixed water land areas, and the U.S. Army Corps of Engineers uses it for post-storm surveys and some other situations. But so for coastal areas, it's really nice because you get, it'll work for the land and the water. You don't have to worry about doing like 2 separate surveys and stuff. So, yep, that's nice. Now goals, really, obviously, our limit review draft is due. So I need to finish that up. I've been making good progress at like page every hour and a half. So just need to buckle down and do that. Start aggregating and weighting our place attachment stuff. I'm like this close to finishing data collection. And then we need to start doing the IRB stuff for our next project. And yeah, keep on writing. It's kind of like always the goal. Right. And I'm also a big printed paper person and like to write my notes by hand. So I need to get those into the Google Drive document with all my notes and stuff. And yeah, schedule my part 1 to 7. I'll be over at winter break. That's all I have.
Jack, have you?
All right. Thanks, Jack.
No, I haven't.
So that was the funding agency that allowed us to do that research, but they have a bunch of like grants and stuff associated to coastal research. So
Okay.
yeah, Virginia Sea Grant, like they lost money to just kind of
Cool. Thanks. So, lab report for today. I'm getting better about the keywords. We got 3. Maybe could use more. Not really sure. But so I started replicating Shi et al. In 2018 by using the hotspot analysis and stuff. And I found a location in Kentucky about so the Mossville. It's a little bit north of Falmouth, and so right here. So up here is Cincinnati, and then right here is kind of where the Mossville is. And the Kentucky Geological Survey has gone through and they've interpreted landslides based on LiDAR, and so that's what I've kind of picked. But they had one that was confident, and the rest of these are questionable, but they all have the same characteristics of being concave and hummocky. So the surface is a little bit bumpy and uneven. So yeah. And this is the process of what the research, what the paper said to do. And so what I did was I pulled LiDAR data about 8 5-kilometer tiles from Kentucky's data set, and they used it for their 5-foot DEM. And I just went ahead and took it and created a DEM with the sampling value of 1, using triangulation for the interpolation, natural neighbor, and I didn't thin it at all. And I use the distance. I'm going to use a distance threshold from the article, which is 2, 3, 4, 5, 6 meters, for each cycle through of the GI statistic. So, but right as you can see, kind of right here at the same spot of where those other ones were, they had so you can see these right here, yeah, right in the curve of the river. Well, here they are again. You can see the relief change right on the edge. So,
is that an old river or is it?
I don't know about the age of the river, but it's probably not terrible. It's not like the New River old, but yeah. So because the New River like was here before the mountains.
Right.
But so this is probably like a third, fourth order stream if you're going to go with hydrologic terms.
So the distance threshold is really for the GI star statistic, right?
Yeah.
Okay.
Yeah. So then I created profile and plan form curvatures, and in the article they referred to tangential curvatures, but they're the same thing as plan form. And so profile is like in the same direction of the slope, and it's more about like which way the direction of your water is going to go, and then your tangential is like what's the curvature like perpendicular to the slope or is it normal, and so that's like whether or not water like diverges, like kind of like the continental divide essentially. And so same area right here that is circled. This bottom one is the tangential curvature. It doesn't look as good. You can't really tell as much from it, just a picture, but like right here you can kind of see like this kind of crest at the top here, and so continuing on, and so I tried to do this last night, working on it, and you couldn't use a hotspot analysis tool on a raster, and you also need a spatial weight matrix, and you can't build a spatial weight matrix without having a feature class.
Yeah.
And so I tried on my desktop at home last night, which is okay, beefy on the beefier side. And I guess Arc Pro crashed, or my computer decided to update or something, because when I woke up this morning, it said that something about snipping tool that I had open crashed. So, but so I got here this morning and I started trying to extract the cells to points or convert them. It was taking forever, so I decided I should probably just kind of like extract by a rectangle of kind of like a focus area, and so now that's running. And at like 10 o'clock, this was at 50%. So I'm assuming that by now or by the end of this meeting, they'll both be done. And then I can do the spatial weight matrix.
Okay, so that all sounds pretty good. Extracting the rectangle is a good idea. The GI star test, I know it doesn't in Arc. I know Arc has to run it on a vector layer, but there's no reason why that can't be done on a raster in theory. And in fact, I think it would kind of lend itself well to a Python-based approach.
Okay.
Do you know if are you in the R class with Yang?
Yeah.
So do a little digging too on the R side and see if R can do a GI star calculation on a raster. I wouldn't be too surprised to find somebody's already made that happen.
Okay.
But this is all great. I'm glad that you're doing it in Arc. This is exactly what I would do at first.
Okay. And so in other news, I added Mendeley as a particle filing system in addition to the paper filing system because some people have given me crap about printing off papers.
I don't know why you guys are so interested in printing off papers. I've never heard of such a thing.
Double-sided.
I know.
I
Apparently,
printed it one-sided.
I didn't know you could do double-sided on my printer. Anyway, so that's gonna
You
change.
told me we could.
Apparently we can. So
You guys hate trees? What is the deal?
I keep my brother in business, so that's what matters. But so installed Mendeley, starting to figure out how to do the whole note-taking thing on there. Maybe, probably not. I'll just keep highlighting. I like highlighting. But half my lit review done. I'm on page 5 out of the minimum 8, so that's working out pretty well. And a handout trick.
So you guys are doing lit reviews for your grad seminar class?
Yeah.
Yep.
All right. When you're done with those, just put them in the put a copy of those in the Google Drive folder in the lit review there, so I can take a look at them.
Okay, sounds good. And handed out candy to the first trick-or-treaters at the new house, which is kind of cool.
Did you get a lot?
There was only 4 people last night because it was raining real hard. So
Yeah.
that's cool though.
The dedicated
Did you
ones.
bring
The
all
dedicated.
leftover candy?
Yeah.
I didn't get a chance to sneak it out of the house, to be honest. Otherwise I brought it. But found a few more articles on landslide inventories that I'm going to talk about next week. Been using them a lot in this lit review, so I think they're really important for background information, stuff like that. And I finished part 1 of season 6 for BoJack Horseman, the final season, and that's a gift from the show. And he's running up the hill. I'm working on it. So, yeah, he is sad. But
I just downloaded it when I was in DC. I downloaded the first episode on Netflix. I haven't seen it. Strongly recommend.
yeah, strongly recommend. Amazing.
Anybody else watch that show?
Comedy?
Yeah, it's a comedy, and yeah,
Okay.
it's a sad comedy, but it's really good.
Okay.
I've heard good things.
Yeah, and then I forgot to put a slide in here about what my goals are. Finish lit review, finish replicating the research, and I guess move on to something that's like decision tree or random forest based. I think one of my articles is about using random forest in Japan, so I might work on that one next.
Yeah, I would say that the next thing you've got a pretty good list of landslide inventories. I think the next thing that you want is a list of algorithms that you want to try out. So I'm glad that you're trying this first one out. I think that's the right thing to do. But before we try out a second one, we should get a pretty good view of the what's available. So start compiling a list of algorithms.
Okay, sounds good. We'll do.
You said you have that hotspot running on which one? On that one?
Yeah. Yeah, it opened. Yeah, it's over there. I opened it.
Oh. I thought it was Jack's. That's awesome. All right, so this week was rather exciting. Aside from this, I'm working on the lit review. I'm also very much a paper person, so.
Uprising. Automate everything.
So I've mostly been taking notes on the papers themselves. So I'm just gotta work on getting that into the lit review for both Brain and for this. And I'm planning on typing up most of my lit review this weekend.
On an actual typewriter?
On my computer.
It's a little warm in here.
Okay, there are 3 of us who like paper and 2 of you. So I was told to report on the Tobler paper, specifically on the non-isotropic modeling, which I had up in here in a second. So one of the main things that I got from it is that isotropic modeling really just simplifies reality. So the top one is showing, I believe, Gauss's geodesic or Gauss's metrics. And so they're useful with like a lot of the models that were being used, but because of GIS, we can create more accurate models now. And part of the reason the isotropic modeling simplifies things too much is that you can often get like data that has, the term he used, real geographic circles have holes and disjointed points. So the bottom one shows isochrones, and it's kind of hard to see, but there's like some holes in like the 1 hour, like in the way you get there. So I mainly got that non-isotropic modeling allows for more of the nuances that happen in real life than isotropic modeling does. And it could be useful to use for like other social sciences, so that way they have like more like data repertoires to draw from. And he also talked about how he got his equation for the walking equation, and it's based off of empirical data from Imhoff. in 1950, and that is a name I've come across a lot when doing research, which makes sense because Tobler's model is often used as well for like cost path analysis. I started the
Oh,
Esri.
let me pause you right there. So the main reason I wanted you to read that was this is the first introduction of Tobler's so-called hiking function, on which massive amounts of archaeological modeling are based. So it's fascinating for me to see this whole line of research got developed essentially out of what amounts to it's a little more than a throwaway line, but it's not critical to his point. Like he's just like, I need some numbers, so let's just like make a hiking function to simulate how fast people walk over different terrain. And like he's actually trying to make this bigger argument about geographical modeling as a whole. But this tiny little detail sort of was enough to sort of launch a whole thing. And Tobler, that's true for a lot of Tobler's work. So you'll probably get a little bit more Tobler reading from me than you will other places, but lots of really, really cool stuff. There's something else about that I wanted to, oh, Imhoff, yeah. So the hiking function was based off of Imhoff, like Colleen said. Imhoff wrote a really excellent book on cartographic representations of mountainous terrain. So if you guys are taking my GeoVis class, we'll spend a little bit of time looking at cartography and mountains. And Imhoff was kind of the guy that aggregated and developed a lot of that literature. So the ways in which we, like even something as simple as like the hillshade representation, right, that we're all used to seeing off of DEMs and stuff, that's kind of got its origins in Swiss cartography, which Imhoff repopularized. Okay, sorry for that introduction, Colleen. Thanks for reviewing the article, though.
The next thing I did, I started the Esri training that Sam gave me the link for. It's going pretty well so far, but that's also because they provide you with the data. So this is just a little bit of what I was doing. It's got like 4 different activities to go with it, and I've gotten through like the first 2. So it's about the Euclidean distance and like direction and allocation. Not quite sure how this is going to be helpful to me quite yet, but I'm sure by the end of this thing I will know.
So the relationship between least cost path models and suitability analysis is actually pretty tight methodologically. So it sounds like you're kind of looking at, this looks like a suitability analysis to me. I don't know what you're actually doing. What is the problem that it's having you simulate here?
Basically it's showing you how to like get to like distance to the closest hospital, direction to the closest hospital, and what is the closest hospital.
Okay, got it. So you're somewhere, and where should you go?
Yeah.
Okay.
I think that's like a classic GIS problem. Like I remember in 459 at NIU, we did like path analysis and like least cost path to fire stations, and like you had to write up a report of where we put the next fire station because there's an area of town that didn't have good connection. So it's real.
There's a lot of stuff in transit too, about like transportation networks and stuff like that. Some pretty interesting stuff. Very like, how do I describe it? Like very mathy and geometric, in like a conceptual way of how like these transportation networks work. I think at Ohio State, Michael Harvey or Matthew Harvey, something like that. Does some work on that. That's like transit, like not too much like least cost path. So.
Yeah, it's a similar, once you do it on a network, right? It's a similar kind of a problem, just constrained a little bit differently.
Yeah.
Yeah. And the next 2 parts are prepare data for weighted distance analysis, and then the least cost path is the last one, find the least cost path. So I'm making progress on it.
Good.
And then the exciting stuff, I got a whole lot of data this week. So that was really exciting. He got back to me Monday. Dr. Gregorio de Souza, he did the paper about the earthworks in southern Amazonia. And I looked and there's like 370 different locations that he gave me. So I got really excited because I might be able to actually look a little more at my area of interest. So I thought it was really cool. He got back to me really quickly and he said he was interested in the results. So I guess after I write my thesis, I should share it with him.
Yeah, definitely.
And this is the data that Dr. Kingle was talking about from Dan Cole. Just looking at the Inca roads and where they are, and that was really cool too. Because it's not easy to find data on it.
Digital all
Yeah.
Oh,
Jeez.
how was developed for the roads? Were they like Roman roads, like very well?
They were pretty developed. Like they were literally used to run data or like run information all the way from like up here all the way down to the end. So like it's literally how the Inca Empire was kept together was through this road system.
What's that big cluster like kind of in the middle? Like Cusco?
I believe Cusco,
Yeah.
which would be like
Yeah.
the epicenter of it. So these roads were used by
Cool.
actual runners, like not llamas, not like actual runners, because they would get the data within like the information within a couple days.
Data.
Is there like,
Inca data.
is there other data associated with those roads? Does he have like other attributes or?
I just saw the road so far. I haven't had too much time to play around with it yet because I was really focusing on the lit review this week. But I mean, so the Inca Empire is really interesting because it was actually really diverse in that not everybody spoke the same language. And so the main way they would communicate is through quipus, which are, I believe, the knotted color strands. And so like they'd run those up and down, literally all the way up and all the way down. And so also when the Incas would take over a different civilization, they would relocate some of them to different areas where they spoke a different language and had a different way of living. So like keep them submissive to like the main government of the area. So it's a really complex empire and it's really cool to like learn about. So I'm really happy that Dr. Pingle got in contact with Dan Cole because this is like a gold mine right here.
Yeah, I couldn't believe it when he said that he had this. And so he had mentioned, like, you know, as they were preparing the exhibit, like everybody had the same sort of like rough outlines of where the roads were, like published in books and things like that, but nothing that was really GIS. You know, they only had the general outlines, and so he had to go and pick through like aerial imagery to actually really finely locate these things. And he said he was using like 1 meter digital globe imagery to do it.
That sounds awful.
Yeah.
I asked him how long it took, and he said it took him a year.
Yeah.
What?
I does not.
Every
It's
day.
for a whole year.
Just every day for a year. Well, gotta go back to Chile. I'm like, all right.
Well,
Well, I
it
know, but I
starts-
mean, like, you know, all you're doing is looking at your history.
I believe that's Venezuela. No, Colombia.
What?
Like it starts all the way in like Venezuela or Colombia. No, it starts above Ecuador.
I can barely digitize
And then
that
it
block.
goes-
Jeez.
Yeah, I had one digitizing assignment that took me hours, and
Impressive.
it was so frustrating. So I'm really glad that I did this. Because that is 1 meter resolution. Looking at all that is, first of all, impressive in its own. Second of all, he literally did the entire road system that we know about.
So this exhibit is still going on, Colleen. I guess it's on through 2020. So the next time I'm in DC, I'm definitely going to check it out. But
Which museum
I
is it?
mean,
I can't. I mean, it's one of the Smithsonian's, but I don't know which. Um,
the American Indian one, the Native American one.
yeah, I don't know.
I live near DC, so I can probably check it out or whenever.
Oh, cool.
Or Thanksgiving. Ooh, future. So yeah, if you let me know what museum it's in, I'll definitely try and check it out over one of the breaks.
It's all up on the web if you just want to Google it's the first thing that comes up when you spell Inca with a K, like Inca Roads. It'll come right up.
Sounds like a strip.
What?
It is in the American Indian Museum.
Neat.
Cool.
So my goals for next week: finish the literature review for Kareem. I've got a pretty substantial outline, so I just really need to like force myself to sit and write it, and it's not going to be fun, but it's going to get done. Hopefully finish the ESRI training this weekend. Email potential committee members. I've talked about it with Dr. Finkel, but I realize I haven't emailed them yet. And then hopefully finish the literature review document for this lab. I've got a lot of notes written on the paper itself, so I just need to type it up.
If you're already working on the lit review for Kareen, that's fine. Yeah, don't worry about the lab one then for now.
All right.
Oh, did you ever get an email back from who was the woman that was the engineer?
No, I have not gotten an email back
Like a
from
second.
Dr. Fiore yet. But I did that paper you asked me about. If I ever got access to it, I got access to it like right after you told me what it was.
Okay.
So I do have access to it now.
Incorporating the cookie.
Gotta incorporate. All right, cool. My keywords. If you're interested, got the hokey colors like last week. This week, I think it was a semi-productive week. I've been like leveraging a lot of my time trying to do Green's literature review, which is fun in a sense, I guess. It's a pain, but I think it's something that we need to do, and I'm really trying to focus on it and kind of crank through it. This weekend, I'm going to be spending a lot of work on it, so start with my going on.
Thanks for posting the hours thing. I forgot to mention this, but I find that really useful. I'm trying to get a beat on. I'm not trying to like keep too many tabs on you, but this kind of helps me get an overview of like what you guys are spending your time on. So if you guys wouldn't mind doing that for next week, I would greatly appreciate it.
Okay. Cool. So partnerships, I set up, I finally got in contact. I contacted the gentleman that runs the Cube, and he got back to me on Monday. And so this upcoming Monday, 4 to 5, we're going to take a tour of it. The VTUAS group, I think it's going to be 5 of us, so Mike's 4 from NWS, the 3 undergrads, and me. Yeah, I guess that's, I'm trying to think. I thought I saw 5 signed up. I'll have to take a look at it. But maybe Mike's 4 and then the 4 undergrads maybe. I don't know. I'll look into it. And then I was emailing back and forth with him about supervised classification of data. So if you see in this bottom right-hand corner, digitized this image that they have of tornado damage. The way he sent it to me was in JPEG format. So he had image like a raw capture of this forest where a tornado came through. And then I think he might have overlaid and drew lines, digitizing it in like, I don't know how he did it, but it seems like it was like kind of like Microsoft Paint a little bit. So he came out with this output of just the tree branches on the ground, which I think is interesting. Me and Dr. Fingerroll were messaging back and forth about it. And there's might be some cool statistics that we can do with just line features of down trees. So I'm redigitizing stuff I did last week. The imagery with just now drawing the lines but that it has a geospatial reference, so I'm doing it all in ArcGIS. Me and Dr. Pino were also talking about geopackages as a way of managing the database. I was able to create a geopackage in ArcGIS, but I wasn't able to create features, nor was I able to import a raster layer into the database. So I think they kind of, it kind of came off like they wanted you to use geodatabases because there's so many more features that they had enabled.
Yeah, I mean, that wouldn't, I don't know, keep pressing on that. I remember that Arc was annoying about it, but I don't remember it ultimately preventing me from doing things. But I can give it a go on my end and sort of see how I did it last year.
Okay. Yeah, it seems like it's like a read-only kind of thing. Not read-only, but like you can pull the data out, but it's finicky to put things in.
Can you edit it? If you've got an existing sort of vector layer in there, can you edit that layer?
Maybe so when I went to go create features in the edit pane, it wouldn't pull up anything. Like I couldn't create anything. I created, I take that back. I did create a line feature in there. I went to go edit it and create polygons or create lines, and it wouldn't work. So I'll look into it. Geodatabases are a pain. I don't know why it's such a weird structure, but
yeah. So do you have a whole slide on geopackages?
pardon me?
Do you have a slide on geopackages?
No. I was just
All right. Well, let me just introduce those to the group then. I don't know how many have you guys. So Hudson and I used geopackages last year to distribute data. The format is pretty new, so I don't think people use these very often. How many have used geopackages before? Just Hudson. All right. So GeoPackage is an attempt to kind of update the vector-based. Well, it's not just vector-based, but primarily what people need is a replacement for shapefiles. Because shapefiles have a lot of limitations. That's a super old format. It's ubiquitous. Everybody uses shapefiles, but they're not great. They have like limitations on size and fields and all kinds of things that make them kind of suboptimal. In the Esri universe, what they replaced them with is geodatabases, but those are pretty clunky, and people in the open source community don't particularly like using Esri geodatabases as data storage. So the GeoPackage was created in 2014 and has been sort of picking up a little bit of steam as basically a replacement, as an open source alternative to the Esri geodatabase. And it all exists in a single file. That's right, isn't it?
Yeah, one file. I think it's an SQLite database.
Yeah. So it can hold. So again, the primary replacement is for vector data, but it can hold rasters just like a geodatabase. I think probably this is where things are going to go. But one of the problems, and won't surprise you guys to learn this maybe, is that Esri doesn't particularly want to push that format. So oftentimes when you're working with these open source formats in Esri, it works worse than if you used, QGIS or something like that. So yeah, just kind of an annoyance, but I wanted to make everybody kind of aware of the GeoPackage. It's nice when it works, but apparently it's not working so well here.
Yeah.
So it kind of just like acts as like a saved instance of all your data, where it's like databases have like branches of it connected to your local file streams, or
I don't know. It is just one file, so it's like you just copy and paste and you're done.
Yeah.
With geodatabase, and you copy it, has to copy all those AE00X files.
Yeah. I'm sure that Esri doesn't want to contribute to GeoPackages as much, especially if they're proprietary.
I don't know. They jump on it. Think it's cool. Plus, with geodatabases, like it's a folder. So, like in the Principles of GIS class, keep having we had a couple problems where people were deleting things inside of it because they didn't know what it was. Or we'd say open the geodatabase and they would open up the file and then start dragging files out of it or dumping files in there. So it's a pain.
Yeah.
The pain of my existence. But yeah, it's interesting. And then we're kind of bouncing ideas with this too because Mike Spohr suggested, and me and Dr. Pino agreed that this would be a good task to give the undergrad students that want to contribute to the group to do. I think it'd be pretty cool, but I wouldn't have them start working on it so we have like an operational kind of format and like maybe do a training on how we want to put this together. Because if we have multiple events that we need to digitize, we kind of have to have a coordinated like structure and pyramid to all of it so that we don't lose it. It's not kind of being thrown around. I was even thinking maybe like a database, like a server would be kind of cool.
Yep, that's the right way to do it.
Yeah.
Another, I mean, an easy way to do this would also be, well, yeah, we'll talk a little bit more about it offline. Yep.
It sounds good. We'll brainstorm. Yeah, this is what I'm looking at. Just digitizing, just for visual reference, putting a line down the center of the tree. Yeah.
While you're doing it, don't worry too much. Just one, like 2 points. You know, trees are straight enough that we'll just do, you know,
Yeah.
bottom of the tree, top of the tree, call it good.
Yeah. Then Mendeley. Jeez. I have a video. I have 2 videos. Is it worth trying to fix what? Yeah.
Link at the bottom right.
Hold on. Share. Give me a second. Who has access to this? Allow visual access. All right, done. So supposedly, if I go back, there we go. Cool. All right. So this video right here is me. Mendeley is this cool citation manager and like database. Lindsay showed it to me, so courtesy to her because it's pretty cool and I think it's useful. So like right here, you saw. So I have these sources. So you can import sources from a variety of different ways, like a Chrome extension, or you can do it manually, or you can use their web. They have a lot of documents inside of their kind of web portal. The I don't know how to say the company's name. Elsevier, yeah. Their web portal. It's free. You get 2 gigabytes of storage, which I haven't been filling up that quickly. Like I have like 40 documents or 60 documents around, and then like 40 PDFs, and it's about like 250 megabytes full. But for instance, I imported some files, and like it didn't import correctly, or wherever it was pulling from, the sources had it named wrong. So you see a bunch of garbage data inside authors. And what I did was I looked up all the ones called undefined, so they had garbage data, and I highlighted them all. As you can see, I'm clicking through showing them. Control A, and then for some reason it didn't show up with Microsoft, the Xbox recorder, but I hit like search and find all, like fill in the missing data, and it automatically, it takes a while and kind of like freezes a little bit, but you see that it starts filling the data one by one, and it finds all the missing pieces. So now they have authors and the abstracts and then the years. It's pretty nifty. I think it's useful. I spent a considerable, like a sizable amount of time this week just kind of aggregating a bunch of sources together. And I built a pretty good database, I feel, of files. So that's going to be part of the lit review process, is going through it. And then also, Lindsay was saying that there's a plugin for Word, so you can just drop your citations, and then you can hot change, like on the fly, swap what citation style you're using. So you could use like APA and then switch it to, Jim was looking for
Mathematical geoscience.
Yeah, mathematical geosciences. So like a pretty niche citation style, and it was right there. Install it and run it. So I think it's extremely useful. Yeah. There's a lot of cool features, but it's kind of escape. There we go. There's a lot of cool features, but you have to kind of explore it, I would say. I added a link to my PowerPoint too. Yeah, this is kind of what I was just saying. Grabbing PDFs sometimes is iffy. So you might have to do it manually. And then I put some notes on like my kind of workflow. yeah, I have 2 gigs of storage, 30 PDFs, only 260 megabytes, so it doesn't fill too quickly. And then me and Dr. Ping were talking about this app called MapSwipe. So what you're doing, and this is a tutorial I was running through on my phone, you like human classify, supervise classify like certain things that they're looking for. So in this instance, they're looking for buildings that might be refugee camps for the UN, I believe. And what you do is you just like you swipe. You can see I'm like struggling with it a little bit. It's not the most refined app in the world. It's a little clunky. But like if you see a refugee camp, you would hit it as green. If you see erroneous status like these clouds, hit it 3 times and you mark it as red. If you're unsure, you mark it as yellow. And then it was struggling with me a little bit, so it gets kind of finicky. But I think it's pretty cool. What we were talking about was to classify the damage, doing something like this, where we present a user with like a picture, is there damage in this or not? Or even doing something to this extent where we are having a bunch of tiles and you select the tiles that have damage. And after a while, we kind of aggregate and train a model of what's damaged and what's not damaged. And I've seen this before. I was telling Dr. Pingo, I think that's what Google's doing when we, like prove that you're not a robot, and it gives you like 9 images to select. Yeah. Supposedly they're feeding in some images that they don't know what it is, and you're helping train their models, classify things. Great. But then they also know
you can make errors, and if it's an error that you think someone would make, it'll still let you.
Yeah, that's true. Okay.
Sometimes I don't like that they're using me as their free labor, so I like click on the wrong squares.
Okay. Yeah. So like, if you ever seen like the street sign and like just a corner of it's touching the polygons that they draw, I think like you're saying like that's maybe not what you consider light, but some people classify as that, some people won't. So I don't know. It's interesting. Yeah, so would this be a good way of classifying imagery? What kind of models is supervised classification training? I think would be interesting to look into, and then look more on the research side, the sources, methods that they're using to train that model, and kind of like how it's organizing, and then find an implementation of this, preferably in Python. So maybe there's like an open source project. I'd have to do some research on that.
It's probably object oriented, just training classifier. I'm not sure.
Yeah.
You probably, if you're gonna have to pick a specific a specific classifier, it's probably a multi-layer network.
Yeah.
So
I have to look into it. Yeah. Interesting. I think it's a method. Other, oh yeah, this came to my mind. Do we have like a way of pushing displays like our computer screens to the TV, like a Chromecast?
Yeah, to the TV in the lab.
Yeah.
Yeah, so there's 2 ways. One is the TV itself is a smart TV, so it should be able to do it if it's configured right. But there's also a little Microsoft, I can't remember the name of it. I thought it was already on the back of the TV, but you can check. It's a little Microsoft adapter that's plugged into an HDMI port. So you should be able to connect to that through Wi-Fi. If you hit like Windows P, I think that brings up the like project menu on the right-hand side. And so there's like a connect to wireless display, and you should be able to see it that way. The only problem is I don't think it works very well for the lab meetings because we got to record them.
Yeah. But I was just thinking like, I think we only really use the TV for the lab meetings, but I feel like it's a cool piece of equipment that we should utilize more.
Definitely.
Especially like we're always showing each other stuff, so maybe just throwing it up onto the screen real quick so we can all see it is
Yep.
a good use. And then my pet projects that I waste my time on sometimes is Operation Automate Everything. So on Amazon, there's some cheap Wi-Fi plugs. So now I have my lights in my apartment. They turn on and off at sunset. There's actually a cool mode if you have like a little Alexa dot. It's called Alexa Guard, where they trained like a machine learning algorithm to detect window breaks and smoke detectors going off. It will notify you if it hears something like that. So when you walk out your house, you say, Alexa, I'm leaving, or you turn it on your phone, and then it'll send you notifications, which I think is pretty useful, especially if I go home for break or be watching my apartment. It also turns on the lights on and off like you would. So it makes it look like someone's there. It's not cyclical. So if someone's like casing the joint, they want to see the lights turn on every day at the same time. They'll kind of move around times. And then my next pet project is when I walk out to my car in the morning, I like to play NPR and connect to my Bluetooth. So I'm going to program my phone to do that. So it's kind of fun things I'm doing on the side. Automate everything. Paper's
Cool.
bad. All right. Yeah, that's all I got. That's some issues. So,
Awesome. Thanks.
Slack. This is it here, so you just go to systems. Okay, so all good.
Slack.
It's up here.
I think it's at the top on the right side, to the right of your tab.
Oh, yeah.
Cool. There you go.
Now, I don't know if this is it. This looks old. Yeah, this is definitely old.
Oh,
Bad Jack. What about the one next over?
I
that's
think
also
there's-
1025.
Oh.
Yeah, keep
Yeah,
keep going
I might know to open yours.
There you
It's
go.
also 10:45.
When did you send yours?
I sent it in the link here.
Oh, yeah. It was,
There we go. Sweet. Sweet. So I'm adding keywords now because that's the thing to do, hot button stuff. But yeah, it's November and we're going to get it popping in here. So spent a lot of time researching Cesium's kind of sandbox mode, they call Sandcastle, where it's kind of you can mess with your APIs and determine how it best fits for your web mapping application or other features that you want to use. So they've got a whole tutorial system and see if I can open it up. And this one was of interest because it was their kind of point cloud classification. So their interaction, like it hovers over a pre-segmented point cloud. So these have all kind of been pre-segmented within the code itself by bounding boxes and things of that nature. But they've got a whole bunch of different animation techniques or other ways that you can implement your web mapping applications. So super powerful, thought it was interesting. It's very customizable and buildable, scalable for other projects. So they've got like a whole list of projects that people have done utilizing their kind of thing. If you've ever done like Esri's JavaScript APIs is very similar. But yeah, they allow you to kind of save files and then push or suggest commits to the GitHub as well. So yeah, it's a cool kind of research area to kind of mess with code in JavaScript. Yep. And then, so another big thing that is kind of the driver of point cloud stuff is the Octree format, and I found a good kind of representation of how that works. So Octree format is kind of a compression format for visualization of the point cloud. And it's basically that they bin like features together or like points together. And there's this hierarchical kind of parent node to child node in like points, and so in this way each kind of segment can be indexed and serialized for easy retrieval and searching. So if you've ever seen, it's very similar to like tiling. We've all seen it like in a large map and how that kind of works. I've got like a little for something here to show. But yeah, so that's kind of the Octree format, and Entwine tile format, which is also uses the Octree structure, kind of builds off this utilizing JSON metadata in its kind of implementation of it. So this makes for more efficient retrieval over like this streaming format from a browser to a client pushing out point clouds in that sense. But it gives a lot of metadata and returns to in terms of bounding boxes, extents, things of that nature, as well as all the different assignments to LiDAR data, whether that's intensity, color, classification, RGB, all that kind of stuff. So yeah, it kind of formats it in that kind of JSON way, if you're familiar with that. And you could easily type this JSON and pull up this New York City point cloud that they have, the Statue of Liberty, and it will completely open up within the browser just from that. So, yep. So yeah, it's extremely important to understand the structuring of how they do that. And if you can see kind of here, like if you've ever seen a map over the browser online, when you shift extents to go in, how they kind of resample the data. So that kind of shift between the extent you're looking at down to a smaller subsample points. So then it only renders the points that are within your viewpoint and doesn't render ones that are culling, it's called, where one point is in front of another. So it's kind of doesn't make sense to render it if it's not currently applicable to the scene. So yeah, we've all seen that. It's this kind of like tiling structure, so that they can compress it and only serve you the data that is important at the time. Yeah, and then some other things I was looking at. Lyft has made all their autonomous LiDAR data available to the public. It is a file. Yeah, and they're proposing a challenge just for object recognition. And yeah, I've always found this stuff kind of interesting. I think, I don't know if you guys have ever heard of Mapillary, which is this kind of object detection from, I think it's Google Street View or something like that, that they're utilizing, and they will segment out important objects that they, I guess, are training their algorithms to catch. So yeah, it's interesting. They have like a challenge, and then the data set itself is massive. So this is kind of an example of it that's kind of outputting, and as well showing like the camera view of it. So yeah, this is all stuff I would love to dig into more. I think it's super interesting. And, yeah, the fact that they've put all their data out there like that, gigabytes worth of data, is quite interesting in terms of research.
Where have those cars been? Like they're pretty like California, like
I
Silicon
think
Valley.
these were in California, like San Francisco area. But I think they also have like Pittsburgh. Pittsburgh is generally a hot area for autonomous vehicles because it sucks, I guess. Apparently, I think I have.
Like it's a worst case scenario.
Yeah, exactly. So like I have like contacts that say like that work for Uber as their autonomous driving division, and they say they do Pittsburgh because you can do it in Pittsburgh, you can do it anywhere. Which I think is funny.
It's also laws too. Like,
Yeah, there's a whole bunch of like different things associated with it, but yeah, I don't know. They're like, yeah. But anyways, I might look into this more. Thought it might be. Don't know if it would be something that a lab could pursue as a challenge, but there's a $25,000 prize or something like that.
do what?
For winning the challenge.
Okay.
When? So, yeah. And then kind of goals and associated stuff. Still need to schedule a meeting. I talked to Dr. Carstensen a couple days ago about that, and just kind of floating on sabbatical. He was at Colloquium last Friday, and I was like, but yeah, just kind of narrowing down when is a good time for that. Yeah, and also kind of pursuing VR plugin work, kind of associated project in regards to the point cloud classification, if that might be a route to take, as well as implementing Entwine and Cesium, being able to at least view them in some stereoscopic format, as well as Unity system, just being able to add some basic interaction points, whether that's selecting them. Then I also got in contact with a company called Aerial Applications out of DC, and they are, I guess, direct competitors with Pix4D. So they, yeah, applied there kind of like as a flyer for a job, and their drone software is basically for utility mapping. And yeah, they sent me like a caliper exam. I had never heard of that, so apparently it's a like aptitude / like personality test that the military uses in order to, I don't know, filter out plebes. I don't know, something like that. So yeah, and yeah, it's like a 120 question kind of exam thing. So we'll see how that goes.
So you haven't done it yet? It's a
No.
to-do thing?
So I've kind of researched like what it's about and all that kind of stuff, what to expect, so I'm not thrown off guard when I have to like answer some math problem or something. I don't know. But yeah, I imagine it's similar to like a gifted program kind of exam, like they do in here, kind of thing. But and assess. But yeah, we'll see. I don't know. So I'll probably end up doing that. And their work is a lot of security clearance based. So the whole timeline for hire could be, I don't know, however long. So we'll see. Yeah. But yeah, that is about it.
Okay, awesome. Cool. Well, I guess that wraps things up. Any last outstanding issues from anybody?
Nope.
All right, we'll go ahead with the individual stuff as scheduled today. I forget. I haven't looked at my calendar yet today. So who's up first, and what time is that one?
I'm at 4.
Oh, 1:30.
Not too.
Okay, 1:30 I think is the earliest one. Okay, cool. All right, we'll see you guys this afternoon then.
Cool.
All right, bye.
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 Was it tornado?